Lungcare AI, and the application is to scan CT scan of your lung, histopathology, and to chart, as well as Azure Custom Vision if you want a no-code environment. So let's get started. You can see you can use for CT scan or histopathology. So choosing for histopathology, for CT scan rather, I'm just going to scan this. This is a benign image, so let's see whether it's going to classify that. So you can see it was able to classify the benign image, and you can chat with it. So we can see the AI is very responsive, and doctors or patients can use this to help their hospital projects. So these are histopathology for benign, but let's see whether it's going to be able to detect that. So you can see it was able to detect histopathology out of our data class. We can also ask it a question. We can ask it a question relating to the readings that we've got, and they're going to answer us like a doctor would, or better than a doctor, because it is reading directly from the internet and from its database. Now to come here, we can easily use the Azure feature. If somebody doesn't really like a code environment, he can go for the no code. He registers and we send him his Azure credentials, so he too can log in and use our model. And hospitals, for example, can use this model in their various projects. So it's lead them to Azure Custom Vision portal. Good day everyone. So we're back, and we can see that the precision is 100%, the recall is 100%, and the AP is 100%. So which means that the model is very much accurate. So let's test it. This is benign lung, just a random one. Let's see. Wow, you can see 99% probability. So let's quickly check the first malignant class, a random choice, obviously the one that we didn't train. Let's come here. Wow, 99%. And lastly, let's come to the squamous cell, still a random one. Wow. So thank you everyone for staying tuned. Thank you. My name is Jeremiah, and the title of our project is Lungcare AI. We are pitching for the AI ML Dev Network Hackathon 2025. Here is our team. Daniel is the CVO, and I am the CTO. The problem statement is that there's always a new case, at least 2.5 new cases as of 2022 of lung health issue. 1.8 globally million. There is about 4,000 new cases in West Africa and 1,000 in Nigeria on lung health issue. And rural clinics image 12% of patients versus 50% urban on lung health issue. And our solution is a low code or a no code environment for people to check their lung image, either CT scan or benign. So the low code is our web application, and the no code is the Azure environment. It is designed for doctors and patients with minimal technical skills. So we trained our image on more than 16,000 images, including 15,000 histopathology and 1,000 images on CT scan, and we achieved an accuracy of 98%. So the model can detect benign, this, and this. So our solution is 100% accurate. The alternative is the Azure Custom Vision, which is a no-code environment which can be laced to hospitals for them to use, because we've already trained our images, which we got from Cargo, so they can easily use our image data sets. Once they mail us, we're going to add them to our project, and we'll send them login credentials for Azure Custom Vision. So here's our architectural diagram. First, users can upload CT scan or histopathology, and users can also chat with the web interface. Now, we use the dense net model 1-to-1 to interpret both CT and histopathology image, and it gives the prediction. And users can also chat if they have a question on what the prediction is. And lastly, users can get to use Azure Custom Vision rather than it. So our solution is on all devices, including laptop, tablets, and smartphones. So users log into the site, they upload their images, and they get reading. They can also chat or use the Azure Custom Vision option. So our target market is Nigeria, because most of these cases is all over the world. However, Nigeria are able to detect a target area which we can start. So we hope to achieve SDG 3, and the uniqueness is in the fact that we used dense net model and also Azure Custom Vision together with ChatGPT interpretation for our AI, and offline for local. If you want to use the model, even though you are not connected, you can use it, and it can both detect CT and histopathology. So it's bridging the diagnostic gap in rural clinic, advancing SDG 3 and 4, as well as fostering collaboration in hospitals. So here's our financial breakdown. We hope to use 2,000 for expanding of data sets, hire part-time medical advisors for $1,500, build offline ready web application with $2,000, pilots in 5 rural clinics, and community outreach with $1,000. And our next step is hardware use, light coding partnership, scale up. Thank you.